We have to remember that solar is trying to replace fossil fuel sources of energy. And those sources of energy have 50-year models, right? And they're not necessarily that much CapEx, right? They're CapEx, OpEx, because they're burning, carbon sources. So if we want to be really competitive, we want long-lived designs.
The Solar Podcast is brought to you by Continental Energy Solutions. Check us out at cesnrg.com. I'm Tim Montague, your host. Today on the Solar Podcast, a single axis tracker made for bifacial modules. My guest today is Mark Kingsley, CEO of Alion Energy. Welcome to the show, Mark.
Hello, Tim. Thanks for having us, and really appreciate the opportunity to discuss our technologies with you.
The only thing I can't figure out, Mark, is why I didn't know about Alion before. I learned about you honestly from John Weaver, who I'm grateful for being such a technology geek. And I know that your footprint has been mostly overseas heretofore, or in foreign markets. But give our listeners some background. You have a very storied background in the solar industry, so please give us some background on yourself and how you came to Alion.
Okay, well, let me do that, and then I'll shift to the product, which I think is always more interesting. I was a senior executive at General Electric for about 20 years in the materials business, and then in the energy business. And then I ran ABB's robotics business, and then I was on the board and ran the commercial efforts at Trina Solar for a period of time. And while I was at Trina, I was building projects with the team in Western China, and I was seeing a number of issues around corrosive soils, causing issues with foundations, but also just the energy loss from soiling that we were getting in those environments. And we were looking, I was doing downstream acquisitions. I was looking to add bolt-ons to Trina's portfolio. And I came across this company in the Bay Area that was called actually Sunprint at the time, now Alion Energy, that was focusing on large format CAD-TEL printed panels. And the challenging news was that there was a valiant effort, but it was never going to have the efficiency that could compete with what GE and First Solar were doing, nor with what was going on at the Chinese labs in China around driving the efficiency of crystal silicon. But they had some really interesting technology around foundations, extruded concrete. And they also had some nice early patent work around robotics to basically do O&M. And so over a period of time, I decided to come back with my family from China and took over Alion from the founding CEO and team. And so that's what we've done. We pivoted the business because we had that core DNA, and we pivoted to solve a challenge for trackers, which is how do you make a 50-year design life tracker? And the goal was to compete with the financing that you see in, say, more mature technologies like natural gas plants. At the time, solar was only getting financed for 12 years, and we wanted to be able to have a more robust design. So we had to get rid of galloping, fluttering. We had to get rid of subsurface corrosion. And then we also knew that the future, because again, I'd launched with my team in China, the low-cost dual glass modules, and they were a prelude to bifacial modules. We knew that modules were going to get heavier, larger, and that was going to cause challenges for torque tubes. It would make them twist. So we said there needs to be a clean sheet design here. So that's why when you see our design, it's an A-frame and distributed loads. It's a much stiffer structure, and it can go up and down hills, and it has a reflective concrete foundation, and we'll get into more of that after. But that was the design. It was basically, with the background in GE, the background in automation, and the background at Trina, we saw a fit in the market for an evolved design. And so we took a company that had some good IP and pivoted it to this. We've been very focused overseas, as you mentioned, Tim, because we were waiting for bifacial to arrive. Prior to that, we were focused on markets that had more soiling issues like Mexico or the Mideast, Oman, places like that, but that also had low-cost concrete because we weren't getting the benefit from our reflective foundations until bifacial arrived. So that's really kind of the journey. But we really like a lot of the markets we've been in. We're doing really well in Brazil, Chile, Mexico before the government kind of slowed solar down a bit. We've got projects in Oman, India. We'll be building in Australia. So there's a good fit for it in harsh environments. And I think that would be the umbrella I would put over everything. We basically have a tracker that is affordable, but also can do harsh environments from desert sands to high wind, hurricane.
And when you say affordable, on a side-by-side comparison with a purely driven pile system, say an Array Technologies or Next Tracker, are you right there at price parity?
Yeah, the donut chart's a little slightly different about where we put our cost. Because of the A-frame design and because of our locking mechanism that we can get into after, we use a lot less steel, but our stiffer structure. So we'll use less than 20 tons of steel and a tracker, which may be 50% or more less than what those traditional torque tubes designed, because they're going to twist, right? And they need that stiffness based on just the fundamental nature of that design. We do have concrete foundations. So we've got various versions of that, but if you're doing a reflective foundation, our foundations may cost more than just a driven post, but they more than make up for it. It's a very fast payback in a bifacial world with the reflectivity off them. But we do have non-bifacial foundations where we split rails. So we did a lot. If you look at the last, I would say 5 years, a big piece of our evolution was we were really pushing road construction technologies of extrusion, how to split flows of concrete, how to segment them with hydraulics. We're doing a lot to basically get down the cost for, say, monofacial systems. But we really see in a bifacial world, you're really well advised to go with a full reflective foundation. It's going to control your vegetation on the module. It's going to give you, 4 or 5% more energy than a low albedo bifacial tracker. And moreover, it's good for against, there's been real issues in the industry recently, especially in Brazil, Spain, around fires under, bifacial and other trackers. And so we basically have a fire break that's built into our foundation. So it serves multi-purposes. And then the final cherry on top is it's also a drive surface for our robotic cleaning system.
Yeah, I want to talk about robotics as well. I'm very excited about the potential for automation in the solar industry. I had Renew Robotics on the show. They're doing vegetation management down in San Antonio, Texas.
Love it.
And of course, cleaning modules is going to be a big industry. When you say 20 tons of steel, though, is that a reference to per megawatt or what?
Yeah, I'm sorry. Yeah, thanks for clarifying, Tim. Yeah, 20 tons per megawatt peak. So yeah, it's a DC.
Gotcha. Gotcha.
And that's
And
your as build. So you'll have a little more than that because you're going to have some scrap that you'll recycle from stamping out parts. But what the customer is buying is under 20 tons of steel.
okay. And so it's a table-based approach. There's no torque tube, similar to Axis in that regard. Um, and tell us more about the drive system. You've mentioned this Geneva gear, which allows you to disengage the drive system or stow. Yeah, explain the drive
Yeah,
system.
we think we're unique. So I don't know if I think we're unique, and we had a clean sheet of paper design on this to solve the problems I talked about before. But instead of using a torque tube, the challenge that everyone knows with a torque tube, and thank goodness for torque tubes, they created the tracker industry. So I'm very, very happy that they exist. But they have a challenge in that as your modules get heavier and longer, right? There's two things that are going to happen. One, your moment of inertia on that tube is going to get more severe, right? So you're going to have more twisting motion, and you're going to need to either add stiffening or you're going to have to add more dampers, and they can be defeated. Like dampers can be defeated by wind angle and speed. And we were looking for a much more robust solution. So the concept was a fixed tilt is a very durable structure. It's a box structure as opposed to a torque tube, which is more like a bridge or a wing structure, right? That's sitting there and can have all those dynamic effects, from fluttering to galloping, et cetera. And so what we wanted to do in a wind event was to use a drive tube and a Geneva gear. And the Geneva gear is the same thing that's in a watch or an old movie projector. If you heard that thing go click, 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 that's a Geneva gear going in and out. And for a low speed structure like a tracker, it's not a car drivetrain, right? It's not spinning at thousands of revolutions per minute. It's a really nice gear in that it basically can disengage the drive gear and take all of our forces, which when we're turning are going through, they're basically on a drive line, a drive tube, and then disconnect all of that. And it makes all the loads go radially down an A-frame. So again, you get a very stiff box section that has a natural frequency greater than 6 hertz, which is again, a magnitudes more than what a torque tube tracker will have. They'll have 0.8, maybe 1 hertz. So we felt that was a really robust design. You can't shake our tracker at the end and make the whole row shake. It basically isolates at each table. At each table, we have a flexible coupling. So every 6 to 8 modules, you can change in any direction, 5%, and so you can go follow the land sinusoidally that way. We thought we were a pioneer on that capability. And, I think those are the main features. And the other thing is we do have a gear. So every vertical upright is torsionally isolated. And what that means, it can never gallop, right? So you have natural dampening in the gear, if you see our system. And it's just like a motorcycle chain. If you've ever driven a bicycle or a motorcycle, they have lash in the chain. That's how they deal with dampening. And we felt, again, that was very robust compared to, traditional dampers. We were going for a 50-year capable type of design. And so we didn't want a lot of hydraulics or other solutions like that that could, fail over time. So that was really the concept behind the design. And you see it in the A-frame, the arc gear, the storm lock, which is a Geneva gear to isolate the drive line. And then you see it in the foundation as well. It doesn't have any subsurface corrosion. You have an extruded concrete foundation.
Yeah, when I see that concrete foundation, I I recognize that yes, you're using roadway technology, and so it is ubiquitous on the one hand. Anywhere you have roads, anywhere you have concrete trucks or cement trucks,
Mhm.
you can do this. But you also then have to bring that heavy equipment to your solar site, which may or may not be so amenable to that. I'm
Right.
just curious, is site access a concern?
Yeah, I mean, I think it is for everyone because remember, you're delivering boxes and boxes of solar panels. I was doing that before when I was at Trina, right? We'd always wonder about the seasonality. So it really comes down to what is the ground pressure and the carrying capacity of the site. I think normally people to build a large solar site are going to, make sure that they have the ability to, drive trucks in that can drop off the solar panels near where they're going to be installed. Um, you know, I look at it and I had to educate myself as well as I came into this, that what is the actual ground pressure? So, I'm not the thinnest person. So I would say that when I'm walking, it's probably about 22 pounds per square inch, right? So a lighter person might be 18 pounds per square inch riding across the site. A mountain bike is 40, right? So a mountain bike tire is a lot more pressure than that. A fully loaded concrete truck, if you look at, they've got four wheels and they've got all the sections of wheels in the back. That's only 20, that'll be like 25, right? Or 30. So it's not much more than you walking on a site. So if you can walk on a site, you can usually deliver the concrete. There are solutions for extreme site. The wind industry actually pioneered because they have to put a lot of cement into piles in some crazy areas. And they basically have tracked concrete trucks that are only they're four psi. I mean, they're really gentle on the site, and that is that's what a track does, whether it be a snowmobile or a track concrete truck, or even some of the products we've had using tracked vehicles. So when I look at that, and then the concrete foundation itself does a much better job of distributing loads. Again, it's going to be 4 psi. It manages not to overturn based on mass, not on frictional interlock with the soil. It manages side to side sliding and earthquake with frictional interlock. That's all very easily tested with a load cell. So, I think that that's a perception people have. We've built on active wet clays in Mexico. We've built on fine volcanic soils in Northern California. We've built over karst in Oman. So yeah, and then in Brazil, we're building in tropical Brazil. So it hasn't been the rate limiter, but it is a perceptual issue that I think it's important you bring it up, Tim, because people have that perception.
And what about brownfields? Is does the system work as a
Yeah.
truly ballasted racking system?
Yeah, so we don't penetrate the ground. So there's basically we're using slip form extrusion equipment, which you reference is from the highway building. It's not new technology. We just adapted it to solar, and you can basically put that on without going into the ground. It'll go on top of a surface. So really, the brownfield comes down to the size and the slopes that you're dealing with. We're going to build a very large, north of 40 megawatt brownfield in the U.S. this year. And that will use a precast because there happens to be a precast plant right near there. So when we look at when we look at which type of concrete solution to use, we look at the area, right? If you're remote, 9 times out of 10, the slip forming is going to be by far the best. If you happen to be on a densely populated area like the East Coast, where there's lots of precast and it's only within like 30 minutes, that's a viable option, especially for smaller brownfields. So it's a good solution. And you can pour in place as well. We've done that in Oman. What we find is that in areas like the US, which has relatively high labor costs, the efficiency of doing slip forming really pays for itself. You're going to go in 2 to 3 times faster with the slip formers. You'll put down up to half a megawatt, per slip former machine of foundations per day. And so we find that really attractive economically. And it's just, easy. So you just have to make sure you've got concrete supply. On large plants, you'll put a batch plant in. We're looking at some plants in the Southwest, but we've built them also, we built one in Lancaster, California, and, Victorville is right around the corner, which is where the main source of concrete in California, Southern California is. So we've become very good at understanding concrete infrastructure. And as I said, we're building in remote Chile, we're building in, remote Brazil, we're building in a lot of places. So you said it well. Everyone solved the concrete solution long before we arrived, right? They've been building roads and other infrastructure with it.
And how does the vertical posts attach to the foundation?
So we use it's the same. We use a two-part thermosetting epoxy, and thermoset means it's a one-way reaction. It can't unreact. It's the same technology that you use for putting in a bridge bolt. So when you drive over a bridge and this cables, maybe you're driving in San Francisco, you're driving over the bridge, and there is those cables holding the bridge up. They're actually held in place with the same type of epoxy. When we always, of course, have done robust design, we test to failure, Tim, and the epoxy never breaks. The steel and the concrete will break when we test to failure before the epoxy. It's very strong stuff. It's been used for over 50 years. It's got a 50-year life rating. And we like it for a couple of reasons. One of the issues, again, before we started doing this, we all had experience building solar plants the traditional way with driven post. And one of the things we didn't like was you didn't know if we really had the frictional interlock you hoped for, right? Because you could put a post in, maybe it wasn't straight, and then the team would come along and push it with a backhoe to straighten it out, right? Your frictional interlock wasn't there. This gave us a visual quality. So I can walk down, or anyone can walk down a row of our tracker, and with a quick glance of the eye can see if there's enough epoxy at the control joints where they're connecting to manage any of the loads that we have. And so I like that about getting rid of kind of the concern about what lies beneath. This gives you a visual ability to scan and know that you've got high quality, robust design in place.
So you're just gluing a bolt to the foundation, and then you're
bolting.
bolting.
We're actually a design foot that lets the epoxy penetrate through the foot. So you have a mechanical interlock as well as an adhesive interlock with the design. There's a groove in the concrete. It's a specifically designed mechanism. And as I said, we test it to failure, and it is 2 to 3 times the wind loads of, say, it'll put this way, it's got enough load to handle 72 miles per hour, and 72 meters per second type of wind loads. So it's a very robust connection.
How does that translate to miles per hour?
It's gonna be like 160.
Okay.
Right. So yeah, so it's so it goes. Our standard design is 47 meters per second or 105 miles per hour. Right. But we've got a modular design where we can shorten tables, add gears, and we can take it up to, the really, really high levels, because we can turn into a 0 degrees non-fluttering tracker design that can't gallop, can't transmit down its drive line any energies. And that means we can do very high winds as well.
Mm-hmm. And you have no concerns about the large modules that are coming down the pike? These
what I'm sad about was my hubris was they were supposed to arrive faster, Tim. We had this design ready, and the issue was we were waiting for these large modules because, again, they have that moment of inertia. We have a big gear, so the gear we have, there's 11 times reduction. It's like a bicycle gear, right? Like your 10-speed, and so the loads on the drive line from that moment of inertia, the damping in there, it was all designed for a future of large format. Dual glass bifacial modules. And so it took a long time for bifacial, longer than I hoped for them to arrive in force. But happily they're here now, and they're wide, they're long, they're 2.3 meters long and 1.2 meters wide. That's a big change.
Are you predicting the demise of monofacial modules?
No, because there's rooftop, right? There's always going to be rooftop. But I believe that if I go back to what I know about the economics of building solar panels, a large format module with getting more power from it is very advantageous from a cost standpoint in your module factory. Your ratio of aluminum to cells is less. Everything gets more efficient, right? So there's economics that are driving this push to bifacial as everyone's trying to drive to an LCOE. And if you make one big square, and people have known this for a while, you have less labor to put them all up. They might be heavier, but less labor to put up less modules means savings on both labor and in the factory. So I think that bifacial is here. Bifacial also, what I find really attractive about it is how it changes the the yield curve through the day, right? It gives you, a tracker gives you a much nicer balance of energy in the morning and the afternoon than a fixed tilt at a fixed angle. And bifacial just accentuates that, right? Again, if you have reflective foundations under there, you really have to rethink how you're clipping. Like everyone has gone crazy on, 1.3, 1.4. They're trying to make money in the morning and the afternoon when it's better. But if you use a bifacial panel and you have a high albedo reflective surface under it, you don't need to overbuild as much because you're getting the same boost in the morning. You're just using a different mechanism to get it. You're using well-engineered capturing of the sun's reflection when it's at low angle in the sky in the morning and the afternoon. So you can change your clipping strategy and reduce your CapEx bill as well. Mm-hmm. So yeah, so that's a long answer to, I think bifacial takes over completely except for a rooftop.
Yeah. Yeah, I noticed that some projects were bifacial here in Illinois this past summer. Mm-hmm. And so it's definitely a thing. So what else should people know about your tracker, and where have you focused historically, and what is your go forward? It seems like you're starting to pay more attention to the US market, but tell us about that.
Well, like any project, we're now in like a third generation of the tracker as we were going through our evolution of the design. And it was originally, we went to Mexico, we went to Brazil, we went to Chile, and we went to the Mideast. And the reason was two. One, we have cleaning robots, right? So we have an attractive value proposition around cleaning. So, look for dust. If I get out of a airplane and the cars are all dirty near the airport, I'm happy, right? There's a market for cleaning robots. But the other, Tim, is, we had a lot of concrete in our design because we were refining it, doing wind tunnel studies with, all the, RWDI and other people. And so we hadn't yet refined our design. So we're using a lot of concrete initially. And the cost of concrete in Mexico is half what it is in the US, right? The cost of concrete in the Mideast is even lower. Cost of concrete in a lot of places. So we were basically going to those markets where we could just have a knockdown, throwdown. We could win on straight cost, right? And as a system. And in the US, we basically would win if we had challenging lands, right? Like one of the examples of the project in Northern California is it's on Native American land. And it had archaeological resources under it. So the tribe did not want steel piles penetrating into the earth. So we'd win in special cases like that. That's now come full circle because finally bifacial arrived. And LCOE is your net present value, your cost divided by the net present value of your energy in the denominator. And once you started getting 4 or 5% more energy from a reflective foundation, the value of that can be, depending on your PPA rate, the value of that can be 3 cents to 15 cents of value, right? Because you're getting energy, it's in the denominator of your equation. So now we're very active in the US and in Europe now because of bifacial finally arrived. And so we've got a lot of nice projects in Texas, Northeast. And again, because in Texas, there's clay, right? And there's good energy. In the Northeast, all the pine up there makes the soil acidic and it's rocky from the glacial erratics. And so, those ballasted foundations serve a couple purposes. And we're growing in Brazil a lot. We've been doing a bunch of projects in Brazil, doing projects in Chile. And then kind of the next big push this year, we're going to see larger volume projects are the Mideast and Australia.
I wonder about stormwater considerations here in the Midwest. That is a major consideration. The authorities having jurisdiction don't understand solar very well to begin with. Mm-hmm. And now you're putting a structure on the land, and sometimes they want you to create, for example, a detention pond for stormwater runoff.
Right.
What are you seeing out there in the world from AHJs?
Great question. And, cement, everyone has a knee-jerk reaction to concrete and cement, right? And that should be any material use. We should be planning for it holistically and understanding it. So we haven't had any project we've had stopped because of that. And the reason is we've got some solutions, and we also thought about the design holistically. So let me talk about stormwater, and then we talk about cradle to grave life of our foundations. So on stormwater, it really depends on what your problem is and how much flow you have, right? Again, this is not a parking lot. We're not covering, 100% of the land. You're doing 33% GCR, and the foundation is not as wide as the panel, so it's even less than that. So usually there's plenty of room for the water to percolate in the soil and go through. But we really look at the flow. There's examples, and I think specifically of an example in Chile, where, there was one company, actually First Solar did a really nice job on their Luz del Norte site, where they put a big berm around the site because they knew the Andes Mountains were there. And when they had a 100-year flood, they had to berm direct the water around the site. And they were fine. Other people didn't, and it washed their solar arrays down the river. So if you've got catastrophic flood potential, I don't care what system it is, you need to use a berm. When you get to more, cross flow a site and flow through the site, there's a couple of strategies. If you have specific local areas, it's an old technology. It's a French drain like you use in your house, right? We can put a little bit of gravel underneath, extrude the concrete over, direct water through an area we have of concern, and we've done that. And then often we see that you can just do compact. You can basically do compact slightly your roads in your site and do a convection swale. So make the road to dual purpose, right? So your water will flow through your site, and then you basically drop it into an absorption swale on the outside or a retention pond. It's going to depend upon which the HJs want. The other thing we always talk to them about is people need to understand concrete. Concrete is 14% cement, which is the high carbon piece of it, right? That's the glue that holds it together. Everything else is, the rest is local sand, local gravel, right? Local aggregate, and it can be recycled aggregate as well, and then a little bit of local water. So when I'm happy to share after with you, or if anyone's question, I've posted on LinkedIn several times, just showing that's the whole CO2 embodied story of our solution. And we really thought about it as we want to be able to pick these solutions up at the end. And that's one of the things we don't have to, New York has a law where you now have to dig down 4 feet and pull out your foundations at the end of a solar project's life. Ours, you're just going to come in with road building equipment. You're going to recover that unreinforced concrete. We designed it very specifically to be unreinforced and be robust. And we basically can regrind it, reuse it as an aggregate. It's a valuable resource. It doesn't have metal in it. It's a really good replacement for mining, aggregate. And then we can, that's one solution, and that's what we see. We see Lafarge Holcim doing something like that in Europe already. And then further afield, we like the idea that you can do something called enhanced rock weathering, which I don't know if you ever heard about, which is basically, if you think about these materials, if you crush concrete into a finer powder, you basically open up its surface for chemical reaction, and it can actually reabsorb CO2 from the atmosphere or from ocean, right? So it's called enhanced rock weathering. So we really think cradle to grave, you're going to get a 50-year life out of this foundation. So you might get a repowering. You're not going to have subsurface corrosion. So stage 1, you're locking carbon away longer. Stage 2, you can use that as valuable aggregate, which will just become more valuable over time. It's an easily recyclable on the surface solution without reinforcements. And then 3, at end of life, you can actually pulverize it, put it on fields, put it in ocean water if you need to, and its reactive surface will actually recombine with carbon dioxide. So we think that's a more holistic way to look at the solution, as opposed to just knee jerk and go concrete, right? It's every material has a good use if it's used conscientiously is our view.
And I forgot to ask earlier when we were talking about the quantity of steel, 20 tons per megawatt versus a traditional torque tube system. How much steel does that have?
There's a range of designs, so it's going to be 30 to 45, right? And you also have to factor in the module power, right, and the weight of the modules, but it's going to be there.
Okay.
It's not quite apples to apples. So remember that when I'm using that number, I'm using their structures, and I'm also using the driven post. And so our steel, it's not apples to apples because our foundation is not a steel foundation, but we're using less steel, which is a high energy material that also has the embodied carbon of shipping it globally, right? Because usually you're not near. There's not a steel plant near a solar site. So we've tried to minimize the steel. The concrete's always local, which helps. And we work hard using, recycled sources and other things to reduce the embodied CO2 in our in the concrete we use in the sites. But the concrete is going to be, it depends on what you're doing. Normally we're going to be talking maybe 160 cubic meters of concrete per megawatt peak. But we have designs where we do like long longitudinal precast where we can get that down to 70. So it depends if you're really, the choice there, Tim, is do you want a reflective foundation or not? And in a bifacial world, the payback for the embodied carbon for using an extra, say, 100 cubic meters of concrete per megawatt is very fast and a very good payback, right? Because it's helping you generate more renewable energy. And so I think that what you're going to see is you're going to see 150s to 170s will be most projects because they'll have reflective foundations. And we'll have special case projects where they'll be using, say, 70 cubic meters of concrete. And that'll be a precast or a cast in place form with a longer longitudinal design.
And of course, concrete has a carbon footprint. What
Mhm.
is the overall expected carbon footprint of an installation of your product versus a torque tube design?
It's better, okay, and especially in a high albedo environment. And let me back that up. One, please go to, if you don't mind going to LinkedIn, look at my post. There's actual math in there, so you can actually go through and challenge our math. What it comes down to is we use a lot of concrete, right? So if you look at kilograms, there's a lot of concrete, but if you look at the actual embodied carbon in concrete, it's not that much. So you have to kind of net that out versus steel. But the way we look at it is it's better because of the once we went to bifacial and reflective foundations, again, factor in how much energy is actually embodied in there. And it takes a year or less, and maybe it depends upon, of course, your amount of radiation, right, in your local area. But basically, we look at the payback. How many months does it take to pay back the embodied carbon that you have in the concrete in that reflector? And it's a really good story, right? And that's without mentioning any or giving any of the benefits of future recycle or future, carbon recapture. It's just basically you're generating more energy from a durable reflector that doesn't need a lot of care. And it basically pays off if you have a high insulation environment like Texas, Mexico, it's going to pay back in months. And if you're up in the Northeast, it's maybe a year and a half, and we can go through that math with anyone. Okay.
Excellent. You mentioned in the pre-show that you're working with PVAL on a report. Tell us about that.
Yeah, I love working with the PVL team. Basically, we had a lot of really nice bifacial results that we were getting from Chile and some other markets, but they're all embargoed data, right? Because it's a competitive advantage for our partners and customers. But we needed to be able to have a very credible third party basically do the testing, control all the variables, and report out, what type of gains we're getting. And who's better than PVL, right? They've been doing it for years. They're not that far from us. They're up in Davis is where their test site is. They've got other trackers up there as well that have published data. So we see some comparative advantages. And so, yeah, we're finishing on actually March 3rd will be a year, will be the full cycle of the year of testing up in PVL. And so we saw it and we're really happy with the results. So they're going to publish a few things. We're going to show that we have like 4 different configurations of a tracker. So we have a tracker with bifacial modules mounted directly to purlins. We have them with like 40 centimeters or, off, and then like 70 centimeters off the purlin. So seeing what, lifting your module off a purlin does. And then we have with no structures behind them. And as I said, it's a couple of percent difference. The max from nothing behind your module to, directly on purlin, the max we're saying is 0.5%. The big story and the big takeaway is having a stable reflective reflector underneath your bifacial module is by far the bigger impact. That's driving the 4 or 5%. And so that's what we'll share all of that. And, as I said, PVL is they do such a good thorough job. We're really excited for that report to get published the next week or two here.
Makes me wonder if somebody's going to start putting even a more reflective surface on top of the concrete, like a metallic surface.
Yeah, we did that. You really got to think about it. Again, I said in the pre when I was like 17 years in the materials business. So I know a lot about, I was in automotive trying to get rid of paint in automotive and doing replacing metallization and car reflectors. So the way I look at it is you really have to think about not only your albedo and your reflectivity, you really have to think of your durability. And so for me, the problem with a lot of materials, and you can see this if you just do a public search on all the rooftops that have been out there where people have put down plastic sheeting, is whether it be an olefin or a vinyl, which is mostly what they are. Sometimes they're silicon. Polymers are always going to be subject to oxidation, right? That's why, or hydrolytical attack, right? That's why we got rid of plastic back sheets and modules. They were working great in northern Japan and Germany. You stuck them in the desert in Chile and they would just fall apart like paper, right? Because they weren't used to that much radiative and hydrolytic attack. So that surface will roughen, right? And so think about your own car. If you look at the front lens, it's polycarbonate and it works fine in New York, but you put it in California, you see yellowing in the polycarbonate, right, on the front. You think about a door mirror, that's the olefin, right? So your door mirror, like an unpainted door mirror that gets all chalky, it's the same effect. So you're not going to hold the same amount of gloss. So what we recommend to everyone is the right product. And again, to use an example from your car, is look at your rear tail light or your side turn signal. That's an acrylic, PMMA. And that material is designed not to change color over multiple years and hold pigment well. That's why it's what's used in exterior paint. So if you have a good exterior paint, you want a high acrylic content with titanium dioxide in it. And the reason for the titanium dioxide is it has a very good, almost like we would say band gap in solar cells. It reflects at a very high percentage at low wavelengths, such as 400 nanometers up through 800. Whereas many other materials, you have to really look at them. They don't have a consistent, reflection across that band gap. You'll see like limestone. People want to put limestone rocks. If you look at what it's doing at 400 to 500 nanometers, it's got an albedo of 15 to 20, not 90. So we really think that you've got to think that through. And so we like, again, an acrylic, like a couple millimeters of acrylic paint on top of our concrete foundation. We think is a really strong story. We've looked at metals, we've looked at other things, but again, you've got to think about durability, oxidation, and how do you maintain that gloss and that reflectivity over the long term.
Yeah. So your major thrust is LCOE, as it should be. And part of that equation is module cleaning and automating of module cleaning. Let's talk a little bit about that. What is the state of the art, and when are the robots coming?
Okay, well, we've got robots, so and we've got videos again on LinkedIn. You can see of them. But I think I'm so happy to hear that the LCOE, because solar, as you know, Tim, you've been at this a while. We've got like a Popeye arm for deflation, right? We've been chasing deflation and winning that curve for 15 years. And so people have always chosen deflation over LCOE, but we've recently kind of hit up against the wall where we're getting to kind of theories of constraints around the stoichiometry of building panels and stuff. So I'm really happy that we're finally shifting into LCOE discussions more broadly. But yeah, so for us on the cleaning piece, I look in the US and I think there's been a lot of nice reports shared. It's not the dustiest of environments, so it's really case by case. So 3%, but 3% to 1% or less is a really valuable amount of energy. So the question is not, do you clean? It's, can you afford to clean? And the reason in the US people don't clean is, one, they've never put in the OpEx budget because it'll reduce the project value, or it's just expensive, right, when you use traditional methods. And that was the goal of our automation platform. So our Spot robot is basically a vehicle that importantly rides on the concrete rail. Concrete loves compression, right? So we can put a heavy vehicle on it. So what's unique about our robot, it's the one heavy robot. Everyone else is using kind of Roomba robots, right? And so they multiple little robots running around the top of the panels. And the reason that does that was I had a really eye-opening experience when I was at Trina. I was paying millions of dollars of claims each quarter for micro cracks. And they would come back, and when we analyze them in the lab, they'd invariably be foot shaped, especially if we were in a low latitude location where the tilt was low, because cleaners were walking on the panels and damaging the cells. And so I also would see that with wind cavitation, would shake the shells, and they could break cells. So I was never going to have a robot that rode on the panel, because I think it just is, you're asking for trouble of massaging cells with loads, you're going to get micro cracks. So our robot rides on the rail, and it just has a brush that comes down. We've got a whole head system that is basically, it's LiDAR driven. So think like a Tesla or a Hyundai, right? It will, it basically reads what's coming. So you don't have to do any bridges between tables, right? It can go over gaps. And so we're trying to do a robust system. And because it rides on the concrete rail, it can have really good range. The entropy to move across a concrete rail is like a railroad versus, a four-wheel truck, a lot less. And so one robot will clean 5 megawatts a night. You could keep going if you wanted to. If you were doing dry cleaning, it can do dry cleaning and wet cleaning, and also do other fluids like albedo adjusters. But basically, it's got hot swappable batteries. And yeah, our plan is we basically will have, on larger sites, you have a team of 2 running 4 robots cleaning 20 megawatts a night is the goal. But we basically have one. We're basically, COVID kind of got us locked down a little bit to do some final finishes to it. But it's the first robots are heading down to a project in Chile. But yeah, we are on a, we did fixed tilt robots before. So this is not our first robot. We've had fixed tilt robots cleaning in Mexico since 2017. And so we took a lot of lessons from that, and we learned that, and we applied them to this newer platform.
Yeah, I think this is going to be a huge part of the industry, and there's many dusty environments that have great solar radiation, but also a large amount of
Yeah.
blowing dust.
Yeah,
So
I think, and there's agricultural, there's lots of reasons for it. I mean, I came out of, GE. So I was always looking at, we were selling equipment to manage the stoichiometry of gas going through a turbine. And, people would kill for 0.5%, right, of more energy, right, from those assets. So I look at if you look at the solar industry and you kind of look at the other industries, you look at gas, you look at wind, those are all rotating equipment. So your service model is about wear, right? It wears out, right? How do I measure wear? How do I measure vibration? Things along those lines. Solar has always presented a challenge to the GEs, the Siemens of the world, the Mitsubishis, because it's not a wear-based issue, right? We have a solid state energy producer called, silicon cells in a panel. But the one thing that is the service opportunity is that dust, right? Yield is always a service opportunity. So having the asset efficient way, so 5 megawatts per machine is asset efficient. Having the asset efficient way to clean them, we think is a really nice opportunity. And then because we have a heavy vehicle, you can also do more with it, right? You can add inspection equipment to it. As I said, you can read albedo and remediate albedo. So the whole concept behind our system is stable power for 50 years, right? That's what we're trying to do in our design philosophy.
love it.
It's
How,
nice to tell the story in the US, because you're right. Also, we've been very focused overseas until the last year or so.
yeah. How far away are we from a 50-year lifetime power plant in the solar industry?
Well, I think we can get there from design fairly readily. Whether people want to tie up our capital in warranties that are 50 years, I don't know, right? So but from a design intent, I think we can get there. What are the things we have to solve? We have to get rid of subsurface corrosion, right? So you've got to make sure that foundation is designed so they're going to last. We've got to make sure that and most of the really good companies and the leading companies have done a really great design on wind design. There's kind of a haves and have-nots on wind design in the industry. And so we have to have robust wind design that can manage, wind events. And so I think that's the other piece of it. And so the industry's come a long way since then. And the third piece were panels, right? Because we had a big issue, as I mentioned earlier, with back sheets degrading over time. Dual glass helps solve that. Bifacial takes advantage of the dual glass. And so now really we've got to make sure that the connectors people are using and the wires and the junction box going into the panel use good weatherable materials. So the good guys they use like Norel, polyphenol ether type of alloys that will last the time. So, you really have to look at the materials and can they do the design and what they're exposed to. Most of the designs out there do not need lubrication. Ours doesn't, right? So they're designed for kind of robust operating in harsh environments. But I think that, the issue will be no one wants to even if a product lasts 50 years, difficult to give a 50-year warranty and tie up a bunch of capital, right, for an infrequent event. I think it's more important that the industry think about 50-year design, right, and then cradle to grave on the product that's going into those designs, right? So our steel can be easily recycled. As I talked about the concrete end of life, what you can do with it. And so I think that that's more important. Individual companies will be able to make their own assessment on can they take that benefit of 50 years. I don't think you can project the cost of energy at 50 years. If I was that smart, we wouldn't be talking. I don't think anyone is that smart to know what the energy cost will be in 50 years. But building for robustness is something we can know and we can control, and that's what we should do. And I said, I think other people are trying to drive that agenda as well, and I welcome anyone that's doing that, because I think that's what we do. We have to remember that solar is trying to replace fossil fuel sources of energy. And those sources of energy have 50-year models, right? And they're not necessarily that much CapEx, right? They're CapEx, OpEx, because they're burning, carbon sources. So if we want to be really competitive, we want long-lived designs.
I love that. Well, Mark, I really enjoyed this conversation. I would like you to share with our listeners how they can reach you.
Okay. Well, I mean, obviously, you can just email any of our team. You can go to Alion Energy's website, right? And there's a contact form there as well. Yeah, I'm also available on LinkedIn, as is our team. I think a lot of you've got a global group of people that watch your podcast, but for the U.S., kind of our leader for the U.S. is Bob Nelson. And Bob is basically rnelson@alionenergy.com. You can contact him that way as well. But, coming through our website is a good way to do it. Coming through us on LinkedIn, we're always happy to talk. And so we'd love, give us your challenge, give us your site that's got karst, give us your site that's got clay, give us your site that's got corrosive ground, give us your site that you need more energy and you need a reflective foundation. And I think we're going to have a very intriguing and happy discussion with you.
Excellent. Looking forward to that. And our listeners can reach me at cesnrg.com/podcast. We do these interviews twice a week, bringing you content from, for example, First Solar with their Plant Predict software for utility scale performance modeling. Uh, we've done a series on trackers, including Axis, the SolX tracker. We're doing a series on agrivoltaics. Running sheep on solar farms is a thing. Learn more about that from Tom Karras. And then thought leaders like Jigger Shah and Hanan Fishman with DC coupled storage. So check us out at cesnrg.com. If you like this content, please subscribe to the channel, give us a thumbs up, share it with your friends, and please reach out to me. I'm TG Montague on Twitter. And I want to thank Mark Kingsley for coming on the show today. What a great product for the US market. I'm looking forward to sinking my teeth into a design one of these days soon. Thank you so much, Mark.